Radio 101 for ESF number 2. The major public safety radio bands in the United States are the VHF low band, 30 to 50 MHz, VHF high, 138 to 174, UHF 406 to 512, the 700 MHz band, the 800 MHz band, and the 4.9 GHz band. The lower the frequency, the farther the signal travels. Another way of saying this is there is less path loss at the lower frequencies. Most radios only operate in one band. Multi-band radios are relatively rare and expensive. If Agency A uses VHF and Agency B uses UHF, they can't talk to each other unless they use runners, have face-to-face interoperability, for example, the people are co-located at the same command post, they swap radios, they relay through dispatchers, or they connect through a gateway. Even if direct contact by radio is possible, what is the procedure? Who do you call? How do you identify yourself on their system? If you show up unexpectedly on someone else's system, their reaction may be, "I don't know you, I'm not going to talk to you." Radio signals in different bands behave differently. The VHF bands exhibit the best propagation in undeveloped and hilly terrain, but poor building penetration. As we move to higher frequency bands, the range decreases, but building penetration improves. Better building penetration at higher frequencies is due to the ability of the signals to more easily pass through small openings, not to penetrate through solid walls. A frequency is a point in the radio spectrum, part of what describes a channel. A channel is a set of parameters that can include one or more frequencies, CTcss tones, bandwidth, modulation, a name for the channel, etc. For example, VCall10 is a channel with transmit and receive frequency 155.7525 MHz, transmit CTcss tone of 156.7 Hz, no receive CTcss tone, and bandwidth of 11.25 kHz. CTcss tones, continuous tone-coded squelch system. These tones are known by several names, such as PL, which stands for Private Line, a Motorola trademark, or Code Guard, Tone Squelch, Call Guard, Channel Guard, Quiet Channel, Privacy Code, Subaudible Tones, etc., some of which names are also trademarked by their vendors. The generic, vendor-neutral term is CTcss, Continuous Tone-Coded Squelch System. CTcss tones are used to mask interference. They do not remove interference. They are useful for masking interference from computers, electronics, motors, etc. It is useful for masking interference from skip, that is, signals that are received from a distant area that would not normally be received in this area. These tones should not be used to block out radio traffic from neighboring or nearby public safety agencies. This is okay for taxis, for example, where they have no need for interoperability with other taxicab companies. But for public safety, this can create a hidden interference problem, which can result in missed calls. If two neighboring departments use different tones, Department A will not hear Department B when they are talking. This might sound like a good thing, but it is not. A portable radio from Department A wants to talk to the fire station of Department A. The user keys up and calls for the fire station, but unknown to him, the dispatch center for Department B is talking on the same frequency at the same time. The portable radio user doesn't realize this because his radio doesn't open the speaker unless the correct tone is received. Fire Station A never hears the portable radio talking because the neighboring dispatch center signal is much stronger than the portable signal and overpowers it. The radio at Fire Station A never makes a sound because the overpowering dispatch center signal is transmitting the wrong tone. The result, the call goes unheard. Radio programming. Programming a radio is not like programming a microwave oven. On a microwave oven, you have a universal programming tool, a fingertip, and it works well with all brands. The graphic user interface is the touchpad, and that's similar. On a radio, every brand has its own tools, cables, adapters, software. There's no standard for frequency, which might be indicated in megahertz or kilohertz, for CTcss, which might be indicated as a frequency or a code, and the network access code, or NAC, which could be indicated in hexadecimal or decimal notation. Several problems can occur if CTcss tones are improperly programmed. If radio 1 is set for transmit tone only and radio 2 is set for transmit and receive with that tone, both radios will hear each other, and radio 1 will also hear any interference on the channel. If radio 1 is set for transmit tone only and radio 2 is set for no tone, both radios will hear each other, and both radios will hear any interference on the channel. If radio 1 is set for transmit and receive tones, and radio 2 is set for transmit and receive tones, both radios will hear each other and not other stations on the same frequency that are not using the same tones. If radio 1 is set for transmit and receive tone and radio 2 is set for no tone, radio 1 will not hear radio 2, but radio 2 will hear radio 1. Any radio programmed with an incorrect transmit tone will not be heard by radios requiring a receive tone, even though they can hear traffic from other radios. What happens when an improper frequency is programmed in a channel? You can hear other stations, but can't be heard by them. Or you can't hear other stations, but they can hear you. Or you can't hear other stations or be heard by them. You can hear other stations when they are close to you, but can't hear them when they are far away, transmitting through a repeater. You're transmitting on an unauthorized frequency, causing interference to a different radio system. You are listening to a different radio system, but think it is yours. You will be very confused. Simplex communications is when radios communicate with each other on one frequency, taking turns transmitting and receiving. 2 to 5 mile range for portable-to-portable communications is typical. Up to 20 miles or more is typical for mobile-to-mobile or mobile to a base station. Simplex communications is very reliable because there's no other infrastructure, but it has limited range. The radio channel uses one frequency. In duplex communications, the radio channel uses two frequencies. Frequency 1 to talk from radio A to radio B, and frequency 2 to talk from radio B to radio A. Each user must be within line of sight of each other, unless they're going through a repeater. Examples: cordless telephone systems, which both parties can talk at the same time and listen at the same time. Duplex is possible without a repeater, but this is not often done in public safety communications. When stations can transmit and receive simultaneously, this is called full duplex. When a different frequency is used for transmit and receive, but not simultaneously, this is called half duplex. Communications through a repeater is typically half duplex. Increasing the height of an antenna increases the range of the transmissions. A radio signal from an antenna at ground level might be blocked by a hill or mountain. Elevating the antenna establishes a clear line of sight path between the stations. When the dispatcher transmits, all units hear the message because the base station antenna is elevated, getting the signal past or around any obstructions. In remote base operation, the base station can be located at some distance from the transmitter. A remote link connects the dispatch center to the base station. This link can be via phone line, microwave link, UHF link, voice over IP, etc. A conventional repeater receives a signal on one frequency and retransmits or repeats that signal on another frequency. It is usually placed at a high location to extend the range. It is used to increase the range between portables and mobile radios, as well as base stations operating in that system. It allows communications around obstructions such as hills, valleys, etc. User radios receive on the repeater's transmit frequency and transmit on the repeater's receive frequency. It is important when discussing frequencies to be clear about whether the transmit frequency is the user's transmit frequency or the repeater's transmit frequency, and the same for the receive frequencies. The user is sometimes referred to as the mobile, the subscriber, or the mobile subscriber unit. On a conventional repeater, when a user keys the radio microphone, the radio automatically switches frequency from its receive frequency to its transmit frequency. The repeater's receive frequency is the same as the user's transmit frequency, so it hears the transmitted signal. It instantaneously retransmits that signal out on the frequency that the rest of the users are listening to, their radio's receive frequency, which is the repeater's transmit frequency. With conventional repeaters, one station can transmit at a time. Other repeaters may be available, but assigned to different agencies. Available airtime on one repeater goes unused, while stations have to wait their turn on another, busier repeater. If many groups need their own repeaters, it can tie up a lot of resources, such as towers and frequencies, especially if some groups only use their repeater infrequently. Trunking is a method of combining repeaters at the same site or multiple sites to share frequencies among users. This allows many more virtual channels, called talk groups, than there actually are frequencies. In a trunked radio system, frequencies are dynamically assigned by the system controller. A user's radio may be on a different frequency every time it transmits. Talk groups are virtual channels, sharing frequencies and sharing time by letting users hear communications only from the talk groups that they are authorized to be members of. User radios continuously monitor a dedicated control channel. When a user wants to transmit, the user's radio makes a request to the system controller. If a repeater is available, the system controller temporarily assigns that repeater channel to the talk group making the request. The transmitting user's radio will give a talk beep indicating that a repeater has successfully been assigned, then the user can begin talking. All user radios monitoring that talk group automatically switch to the frequency of the assigned repeater and hear the transmission. When the transmission is complete, all radios return to monitoring the control channel. If someone in that talk group replies to that transmission, the process repeats itself, requesting the assignment of a repeater on a control channel, and so on. Multi-site radio systems can be either conventional or trunking. With conventional repeater systems, repeaters may be on the same output frequency but use different input frequencies. The output frequency is another way of saying the repeater transmit frequency. The input frequency is the repeater receive frequency. There may be linked repeaters on different frequencies, both input and output, tied together by some linking circuit, which may be microwave, voice over IP, etc. There may be remote receiving sites. These are sometimes referred to as voting receivers, where the receive site receiving the strongest signal will relay that signal to the repeater transmitter site. There may also be simulcast repeater systems, where repeaters use GPS or other precise timing to perfectly synchronize the phase of the transmitted signal so that a receive station located between the transmitters will not hear signals beating each other. They will hear a usable signal. With trunking systems, there can be issues about roaming onto different systems and simulcasting repeaters. In this example, the user to the left cannot hear or be heard by the repeater that the other users are using. The signal is obstructed by a hill. By selecting a closer repeater, that station can now reach all of the other units that are between the hills. In this example, we see linked repeaters on different frequencies. If a transmission can be heard by either repeater's receiver, it will be retransmitted by both repeater transmitters. Users must manually change the channel on their radio to the repeater that covers the area where they are. With voting receivers, the receivers at different locations listen on the same frequency. In this example, there is only one transmitter site which covers the entire area. In general, increasing antenna height increases range, increasing power increases penetration. With voting receivers, users do not need to change channel depending on their location. The voter automatically picks the best received signal and sends that to the transmitter for retransmission. In a simulcast system, all repeaters transmit on the same frequency at the same time. Transmitters must be carefully synchronized to prevent interference in overlap areas. This is usually accomplished by using a GPS timing signal. If you receive a trouble call like the radio system is down, you should first determine what kind of system. It could be analog or digital. If it's digital, it could be P25 or proprietary. It could be a conventional simplex system, a conventional repeater system, or a trunking repeater system. If it's a conventional repeater, it might be single site, voted receive sites, linked repeaters, or simulcast. The system could be VHF, UHF, 700 MHz, 800 MHz, or a combination of these. If you hear the tower is down, does that mean the tower collapsed and is a twisted mass of scrap metal on the ground? Or does that mean the tower site is not providing service because the equipment at the site is damaged or without power? You can aid the repair process by compartmentalizing the problem. Is the problem with the user radio, the repeater, or if there is one, the link? Problems in the user radio could be an untrained user. It could be trying to use the radio beyond the coverage area. or shielded by terrain or some other obstruction. It could be a loss of power at a base station or a dead battery in a handheld radio. If the problem is at the repeater, is it caused by a loss of commercial power, backup battery, or generator fuel being exhausted? Is it caused by antenna failure, perhaps wind or ice damage? Or was it caused by a catastrophic site loss due to a tornado, fire, explosion, or other calamity? If the problem is with the link, is it caused by loss of power, antenna failure, or a problem with a telco circuit, such as a phone line or an internet connection? Interference is a possibility at any location under normal or disaster circumstances. There's no point sending an antenna installer if a generator technician is needed. With a few questions from you to the caller, you may be able to compartmentalize the problem. In a telco or cellular telephone network, there is a network operations center that knows the status of the network. In land mobile radio, or LMR, there is no the network. Each radio system is independent. A statewide system or a trunked system may monitor the status of some components of just that system, but not all LMR systems in the area. There is no one place to go to learn the status of all LMR systems. Commercial Mobile Radio Service, CMRS, networks may have a network operations center. Most public safety radio systems are not CMRS customers. They are government-owned LMR systems. Every technology has its limitations. Some of the limitations of land mobile radio are: radios without infrastructure have a short effective range, approximately line of sight. That is, how far you could see if you were at one antenna looking towards the other antenna. Repeaters extend range, but they require power. Repeater systems and networks extend the coverage area, but increase complexity. Trunked radio systems increase capacity, but are much more complicated and are not easily transportable. Users cannot program radios. This must be done by a technician for those that are FCC Part 90 licensees. That does not apply to NTIA authorized stations, that is, federal government stations. Some agencies' radios are password protected. If their technician is not a first responder and won't share the password, field programming is not possible. Rules and regulations are ambiguous and arcane. They are written for day-to-day operability and interoperability, not catastrophic disaster response. All radio frequencies used by responders should be coordinated with the DEC Group Frequency Manager before use. Programming in the field, while under stress, is more likely to lead to errors. Front panel programming takes a lot of time. Programming by computer takes time to set up the first time. Then it is fast to program multiple radios with the same channels. Model-specific hardware and software complicate field programming. Cloning to program multiple radios is fast, but requires model-specific cloning cable and radio passwords. The trunked radio system key is needed to program radios, but it is seldom shared. The system technician may be too busy to program the key and frequencies into visiting responders' radios, or the system technician may be a casualty of the incident. Here are some problems you may be asked to handle as ESF number 2 and possible ways to handle them. If you get a call from a state or local official other than a simple question that didn't come through state ESF number 2, you could refer that call to state ESF number 2. If you get a call about radio, telephone, or internet in the Joint Field Office, JFO, you might transfer that call to the JFO Logistics Section Communications Unit. If you get questions about radio frequencies or channels, you should transfer that call to your Spectrum Manager or Frequency Manager. You didn't deploy your Spectrum Manager? Shame on you. The Spectrum Manager needs to be among the first boots on the ground. Once the Spectrum Manager gets behind, they can never get caught up. Federal, state, local, or private voluntary organization, non-governmental organization needs radios, needs help programming radios, needs help repairing, installing, or acquiring antennas, needs temporary tower, needs Wi-Fi, needs internet backhaul, satellite communications, repeaters, remote base stations, trunked radio system. You should get the specifics of what they need and then task that issue to the Disaster Emergency Communications DEC group of ESF number 2. Before you start taking calls, work out with the DEC group whether they want to handle generator issues at communication sites or whether those calls go to ESF number 12. If you receive offers of donations of radios or communication-specific supplies, services, or technicians, track or transfer that request in accordance with the JFO donations policy. If you get a request from a broadcast station that needs help, including generators, refer that call to your FCC liaison. This question comes up frequently. If FEMA installs equipment or an entire radio system for the locals, can the locals keep it? No. Non-consumable items purchased with Stafford Act funds will be recovered, refurbished, and reused on a future disaster or disposed of through normal U.S. government excess property procedures. Summary. This radio stuff is complicated. Get the right information on the first call. If you need it, FEMA can get it, whatever it is, if it's justifiable. And spectrum managers, don't leave home without one. Some of the material in this presentation was adapted from the link shown on your screen. Thank you.